Okay, it looks like I've got some sound, and I am about 6 or 7 minutes early. I'm glad to see you aboard. If you would please mute your your video and your audio. And we are a little bit early, and as folks come in, they'll be able to get. They can always scroll back, because once I've finished the screencast, I'll record it and place it over at YouTube. Now, I think we're okay. Everybody is kind of settling into the logistics of this. And again, today, I want to just do a little bit of housework or logistics, if you're homework, housekeeping, make sure we're all on the same page. And the first starts with the assignments that are due. Nolan Plastics, that should be uploaded by the 9th, which is on Friday the 9th, okay, at 5 p.m. And then you've got you got chapter 1, okay, and that is due at midnight, no later than midnight on Friday. And the same thing for chapter 2. Those are both open book, open notes, and tell you how many points they are. And you can click on them, and you can see how much time you've got. Okay, and there's no time limit on that. It's 35 points. You get 2 attempts. And then on chapter 1, same story. Pardon me, chapter 2, and just a quick preview, and you can see the items, the types of items are going to be objective questions. Now, I want to go back over to we've been over at the syllabus area, all right, and we've talked about Nolan Plastics, and we did a little bit of discussion of it on Monday. So I'm going to move us ahead. And again, I just want to emphasize something in the announcements. You're going to typically see 3 things in here involving screencasts. Once will be a recording. Here was the invitation to the recording for Monday, and then here's the actual recording, okay? And then here's the invitation for today. And once this session's finished, I'll record it and post it at YouTube. Then you're also going to see virtual office hours. I had some yesterday from 3 o'clock to 5:30. Today it'll be from 4 o'clock to 5:30. And again, those are there for anybody who wants to come in. If you have a question or issue, I can try to deal with it and help you there. And I can do as much there as I can do sitting in my office over in Shawnee. So I just wanted to make sure that we were on top of that. Now, I'm going to go now over to the modules area. All right, and I want to emphasize that I really encourage everybody to go over and take a look at Excel Easy Solver. We'll go take a look at it for just a second. This is a great website. I talked about that I think on Monday. It has excellent resources. Okay. And then a couple of other sites that deal with and that's over here in this that deal with Excel, okay? And I wanted to find those here. The Excel, there's a PDF on Excel's optimization. It's an excellent bit of it, I guess kind of a PDF, a teaching guide. How to use Solver and YouTube. There's a link to YouTube. And then here's Solver and Easy Excel. Okay, and then a link about the what if analysis in the Excel Scenario Manager and Goal Seek. Okay, now I also and this is getting this is for this week. that all was last week. This week, I also want you to go over and take a look at the Excel solver. This is a resource on the GRG nonlinear and what that applies to. And we talked about this some in class about the type of data or data points you're dealing with or distribution. And the same thing for Excel evolutionary, okay? And you can see we have the Nolan Plastics key. I'll go over this. I'll go over Nolan Plastics, the key, on Monday, okay? And I have it on mine. You can only, the only reason you could see it is that I'm doing a screencast, but the things, when you see that mark, that means it hasn't published, and I'll do that on Monday. They're the two, of course, the two exams. Well, I want to move us ahead, okay? So we can, and we'll jump ahead a little bit on what we would have covered on Monday, okay? And on Monday, I'll just go back and go over the Nolan Plastics key. So this gives us a chance to preview some of the upcoming cases, and you're going to see that we have M&D Chemicals and PAR Inc. Those are two cases that are due on the 16th. And then you'll have an exam over Chapter 3 and Chapter 4. Now, the M&D Chemicals problem starts, M&D Chemicals starts over on page 52 in the textbook, okay? And I want to pop over here for just a minute. And this is a talk about a simple minimization problem. And so you'll want to look at that. You'll want to look at that in your textbook. And basically, what you'll see here is that we're now talking. We're working with what I call a very simple load problem, load bearing, and that is we want to get the optimal mix of products, okay? And here they give us the definitions, and then we want to minimize, okay, the production costs, okay? We want to get the minimum production costs, okay, so we can get, of course, we can then optimize our profit. And they walk us through building the model, and here we see it, okay? Then we start with 1A, and this is a constraint that's built in that we've got to make at least or greater than 125 units of product A. And they have two different products here. Then then for both of them, they have to total 350 gallons. We've got 1A and 1B is greater than or equal to 350. So we're building this model, this mathematical model, okay? And it's a minimization problem. Then they walk us through over here, and a limitation of 600 hours on processing time. So now we have the full, if you'll see right here where I've got my cursor, I'm moving it. We have the mathematical model, okay? We have an objective function, okay, where we want to minimize production time and processing, total production and processing time, given this subject to this constraint in terms of the demand for product A. Now, the authors are going to, as I mentioned before, and this is over in chapter 2, the authors will walk us through the linear graphing of that, okay? And they'll literally will go through the linear algebra, then graph it, and show us the feasible region. And it's this region right here. Okay? And then they begin to walk us through some of that issue, and they give us the summary of graphical solution procedures. If you really want to do that, be my guest. Frankly, I think it's a lot of work that doesn't get you too much. Now we also want to deal with the issue of what we call surplus variables. And there's the whole problem, the minimization problem with our constraints. And then we have surplus or slack values. And this means that we have an optimal solution, but we have some extra. We have a slack or surplus variable. And they walk us through again that whole process. Okay. Now, as I mentioned on Monday, you're gonna see, and this is of course from the web files, MD, and the files are over there in the files section of Canvas. But the bottom line here in figure 217 is they're showing us the solution for this, and we've got the optimal objective value, and here are the variables, and then we have slack or surplus in terms of constraint 1. Okay, and then they walk us on through the constraints, and if there's any allowable increase, and then any dual value. We'll talk about dual value, okay, because dual value is basically, it's also what we would call a marginal gain or marginal increment that we can get or obtain. So you'll be working through M&D chemicals, okay, and they give us some alternative solutions, but that's par Inc. Now I want to go back here for a moment to the classroom, okay, and I want to show you the file that you're going to be using. Okay, so we'll go up to the files section. Okay, and we're going to come down to the MIS web files, and we'll find them here. Pardon me, MS 13, Management Science 13th edition web files. And we'll download those. Okay, and we're working in chapter 2. And you remember I mentioned the other day about lingo files. There's the textbook has a companion site which has an application there called Lingo, where you input all of the data. Okay, and I don't like it because most of the rest of the people on planet Earth will be using Excel, or they'll be using another product. So that's why we do the Excel files, and you open the Excel file and you're going to find M&D. And what I want you to do is pretty simple. As I've said before, save this to your desktop. We'll enable the editing. Okay, and I'm going to click Save As, and yeah, and it's a copy of M&D or whatever. And then I'm going to put my last name, and I'm going to save it on my desktop. Why? Because if you don't do that, the file is basically in limbo. It's a display. And so if you try to do something with it, okay, you're going to have some problems. So you're almost better off to go ahead and save it to your desktop, close it off, okay, and then come back down to your desktop, and there it is. You can see I got a lot of junk on my desktop there, and then you can open the thing up and work with it. Okay, now let's take a look at this for just a moment and just kind of see what we've got going on here. Now here we have processing time and production costs. Okay, and I have a task for you to perform, and I'm going to diminish this down and go back over here for just a second. Okay, and go into the modules area. Now, as you recall, and I'll just open this back up, PAR Inc. is also in there as well. Okay? And if we don't get to talk about PAR Inc. today, we'll do it on Monday. But we'll go back up here to the modules. Okay. And yes, we are working a little bit ahead because there'll be some points where we can't do so. Okay, because this stuff's all due next week. That's okay. Now I'm going to click on the link here, and here's where we'll get the directions. Pardon me, I'm sorry, not up here, but up here. Excuse me. Preview, okay. Preview, we're going to preview M&D chemicals, and that's over, and that's pages 52 through 57 in the textbook, okay? And I'm going to copy this because we're going to do some work with constraints there. All right. And then I'm going to go back down to my open file. And let me move this up. And I'm going to insert a text file. And I'm going to find that here in a minute. I always do this to myself. Okay, here we go. Text box, excuse me. And just to make it a little easier for myself, this is how I would do it. And I would bring it up, you know. And here I'm asking you, okay, to change some of the variables. Now, let's talk about this for just a moment. All right, and let me move this out here over. Okay. Now, as you can see, we need to find the left-hand side of the equation and the right-hand side of the equation. Okay. If processing time is incremented up 10% per product and the time available is reduced, okay, by 8%. And you say, what do you mean by the left-hand side and the right-hand side of the equation, okay, or the LHS and the RHS? Well, if you go over there to page 55, you're going to see, okay, you're going to see in the middle there the minimization, the objective function subject to the constraints. The right hand is everything that's on the left hand is everything that's on the left of the equal sign. The right hand is on everything on the right hand of the equal. That's what they're talking about, the RHS and the LHS, okay? Now, if it's that big of a deal for you, and let's go back into the bookshelf here, and I'm going to do a quick search. I'm going to do RHS, see if I get anything there, okay, and and what that definition is, okay. And we can see here, and we'll take a look here for a moment at page 51, okay, and they're showing us a solution, okay, and that's the right-hand side of the equation. The LHS is on the constraints, the left-hand side. Okay? So we'll go back over here to page 52 or 53 where we were. And let me back us up here Sorry about that. And they give us some of those specifications, but we're going to go back over here to M&D chemicals. Okay, and there we are. Now I'm going to go back here, and I want to find the LHS and the RHS. It's the processing time, okay, per product, okay, is incremented by 10%, and the time available is decreased by by 8%. Okay. Now let's go through here, because we have the time available, we have each product, we have the production cost, and we have the time. And then as we come out here, we come to the minimum total production. These are constraints that we set in. We've got to have at least 300. We have to create 350 units, and product A has to be at least 125. Okay. Then we come down to the gallons produced. These are the decision variables, and these are what we want. And we can infer then we've got the maximum cost. This is what we end with production. Our demand for A, total production, the processing time. Then we see the right-hand side for A, and let's press on that. And processing time. Okay, now let's go up here for just a moment, and you should have an Excel solver on your machine. If you don't, if you're working in the lab or you haven't, I've shown you guys how to go in and add it. And here we see we've got the parameters. We set the objective is in B17. We want to minimize the total cost by changing the variables B15 to C15. Okay, and B15 and C15, we want to change those, how much we're going to produce, and they're subject to the constraints B21 through B20 through B21 have to be equal to or less than D20, D21, left hand, right hand, and then that constraint on B22, the processing time. And we're going to use a simplex LP. Now I'm going to do the solver here. Okay, I'm just going to run solve. And it says we found a solution. All constraints and optimality conditions are satisfied. All right, so we're good with that. All right, and we do have a solution. So I'm gonna generate some reports here. Okay, and I'll be coming back to them as we go through. Here's first the answer report, and if you want to get all three of them, hold your cursor down as you highlight them and then click OK. And you'll see we have answer report number 1, sensitivity report number 1, and limits report. Now, this is going to look a little bit different than the textbook normally will show you the lingo output. Okay, but you could but it's the same answers, just formatted differently. And here we are. This shows us the answer report. Okay. All right. And here's the objective function, the original value, then the final value. Okay. And then the gallons produced. Okay. Original value and the final value. Okay. And then if we have any constraints, what those were. Now, when we're looking here, we look for any slack And here we see some slack. And I'll highlight that for you. This means we can produce some more. We can produce some additional product A. Okay, and we've got a surplus variable, a surplus there that we can generate. Now, if I looked at the sensitivity report, the sensitivity report, and I clicked on it just now, is going to show you how much of an allowable increase can I do with product A. Quite a bit. That's the allowable decrease on product A because I have a slack variable in A. You'll see it's mirrored here in product B of a very small allowable increase. Then we get some things called the shadow price. And the shadow price is the same thing as what the textbook, when the textbook uses the term dual values. Okay? And then we can pop over to the limits report. And we're going to go through these reports so you'll get to where you see them pretty quickly. And here we see the limits report is the one that I like in Excel. I think is the most understandable. First of all, here's the optimal solution. Here's the value for our decision variables. Here's the lower limit. Here's the objective result. Here's the lower limit, the objective result, the upper limit, and the lower limit. Okay, so we know we have an optimal result here because we're within limits, within tolerances. If I go back though, and I look, I could produce more product A. Okay, and thereby change also the constraints. So I look for that slack surplus. Now, what I'm going to have you do, okay, is change these variables and see what you get. Okay, and I've got a question here. Let me see if I can answer for just a minute. All right, glad to see you. Did you have a question? Of course, if anybody who comes in late, never fear. You can always, I started about five or 10 minutes early, and I often do this for a simple reason. You can go back and look at the recording for what you might have missed at the start, okay? And if you want to bug out a little bit early, it's not gonna hurt you or me, either one. That gives you as much flexibility as I know to do. Now, again, for M&D chemicals, which is due next week, I want you to find the left-hand side and the right-hand side. If the processing time, okay, is increased by 10%, all right, and the time available is decreased by 8%, okay? So it'll be interesting to see what that looks like. And all you're going to have to do is just apply those increments or decrements to those totals. Somebody's hailing me for chat. What we're looking at right here, Hudson, is we did Friday. I showed everybody. We talked about Nolan Plastics on Monday. Okay. And you'll want to go back and take a look at the screencast earlier on. And what we're doing is I'm jumping to some of what we would cover Monday, because Monday I'm going to preview the answer for, I'm going to go over the solution file for Nolan Plastics. And since we're working on M&D, okay, I'm probably, and we may get some to par, but I'm kind of working ahead. No problem. That's fine. It's a good question, because you want to stay up with this and be okay. And like I said, now, again, as we just showed you here, when you do Nolan Plastics, I want you to do some work with the variables. Folks, here's basically what I'm going to do each week with these cases, all right? I want you just to try them. If you try them and you turn them in, okay, I'm going to be okay with that. And then I'm going to go over the solution typically the next Monday, okay? So that you can try it and you don't get penalized for trying it. I already have exams and quizzes. I have a final, all those kinds of things to grade, okay? But these cases I do in almost every class I teach. I want to treat them like a workshop, so we can get past some of the computational issues and get down to the issue of, okay, what are we trying to find out, right? And here in M&D chemicals, okay, we're doing a minimization problem, okay, and we're trying to minimize, okay, the amount of time, amount of processing time and production costs given demand for the product, and they're producing gallons of some kind of paint or something like that. Okay, so that's kind of a good prep for you for M&D chemicals, and to kind of get you started on that. But now remember, M&D chemicals is due the 16th, all right? But you can turn it any time. And what I would do is next Monday, now we've covered this, so next Monday I'll probably talk about PAR Incorporated, or I may move on, okay? But again, this is what you'll need to be doing for this, okay? Now, I want to come back up here for a moment, and I'm over here in the textbook, all right? And they walk us through the solution, and this is using the lingo business, okay? And then they walk us through some special cases like we're going to run into, okay? Like we're going to run into with PAR Inc. All right. So now I want to take just a couple of minutes or so. All right. And I'm going to close that window. And I want to talk for just a few minutes about the M&D case. So I'm going to go back over here to the modules. Okay. And pardon me, PAR Inc. Now it's due on the 16th, and like I said here, on Monday I'm going to go over the key for Nolan Plastics, but just try and upload it, okay? And then I'll go over the key, all right? Now, and you get credit for just trying on these cases. That's all you got to do. And now, on PAR Inc., that's a little bit different critter. And here I give you PAR Inc., and this refers to pages 87 through 91 in the textbook. So let me go back up here, okay? And I'll do the search for PAR Inc. All right, and we'll take a look at this. Roll through here. Okay, and I'm going to back off for just a minute because, as I have in my notes, I believe it's the appendix. Appendix 2.2. So let me go back over there. And I'll navigate there real quick. Here we go. Now, Appendix 2.2, this talks about, solving linear problems with Excel, and this deals with the PAR Inc. Okay, and I want you to work through, okay, pages 82 through 87, and we're going to work with PAR Inc. Now, you remember when we opened the zip file earlier for chapter 2, and here's PAR Incorporated, and I'm going to open it up. Okay, and here we are. They're making bags. All right, this company makes bags of some type, and they've got a production time schedule or table, and they have, when they make these bags, they have the following components: cutting and dyeing, sewing, finishing, and inspection and pack. And then they have the profit per bag. That's for their standard bag. Then the deluxe bag, and the profit per bag. And then the time available for each of these. Again, this is what we call a load balancing problem, where we're trying to determine in the process of tasks. Now, you remember early on, and one of the reasons I use these two examples is M&D Chemicals dealt with handling stuff. Okay, they were making paint or whatever they were doing, but they were handling chemicals or components that go into a particular chemical product. So this time I wanted to focus you on handling or optimizing time, production time. And this could be stuff involving people and machines, or people alone or machines alone. And you can look in the case, and they'll give you some background on it there in pages 82 through 87. Okay, again, that's pages 82 through 87. And they'll walk you through the case. And as you have seen, I'm going to ask you to change some of the variables and run that. Okay? So, and we'll spend some more time talking about that, but the textbook will give you the background, okay, in terms of the Excel solution, and it walks you through the dialog box, and it shows you the Excel solution. And we've got an introduction to solving linear programs. Now I'm going to go back up here, all right? And remember, let me go back here for just a second, okay? And I'll just show you. Copy that. And I'm going to go back over here, and I'm going to click Insert Text Box. Oh, I don't want type. We're going to go text box. There we go. And I'll just size this up so I can see it. You say, should I do this, Dr. Harmon? Go ahead and do the text box with the instructions. Yep, I would, so you can be looking at one screen, not several. Okay, now I can just simply, manipulate the variables. And here we want to compute the left-hand side, right-hand side. Okay, there's the left LHS, left-hand side. Do you see how complicated this is? I don't know how you'd ever understand the difference between the left-hand side and the right-hand side of an equation. I'm not sure you could handle it. I'm teasing you. I'm being sarcastic. The truth is, the underlying mathematics of this is pretty dense. But at at the top, at the input level, okay, the hard part for all this, everybody, again, this is the practical piece of this course, is where did you get these data? And these are either based on historical data, okay, or industry standards, or some combination of them. And the textbook doesn't go into all of that for a very simple reason. Those are another set of courses that would be part of a bachelor's degree in management science, and where to get them and how to calculate them. Okay, and as we talked about the other day on Nolan Plastics, if you're not quite sure, you can always simulate these numbers. Okay, now the cutting and dyeing will be to use these where you have a fraction, you'd have to use the random tool. Okay, if you're working with whole numbers exclusively, you can use rand between. Okay, and when we get into simulation, we'll see some of that. But in this case, we're talking about processes. Okay, and let's go upstairs. And of course, this is what you'll be working on. This is going to be, this is due on the 16th. Okay, so we'll review it again a little bit on Monday, because I'm going to spend some time Monday showing you the key to Nolan. All right, and spend a little more time. We'll cover Nolan, and then then we'll just kind of quickly review M&D, and then this case, and then we may launch ahead and start to look at some of the later the cases. So as you know, if you took 1123 with me, sometimes we would jump ahead a little bit because we're going to come to a point where we will have to slow down. Okay, and here we have, and let's just go ahead and we'll look at the solver on this. So I'm going to click data. Okay. And there's the objective function. I want to maximize my total profit. How do I know? Well, here's the profit per bag, and that's an output that I want based on those operations. And those are an issue. Those are a function of the amount of time I have available. Then the decision variables. Okay, how many bags do I produce of standard, that's one type, and of deluxe, and maximize my profit while minimizing my costs. And then we have the constraints. And do we see the constraints B21 to B24? That's the left-hand side of the equation. And those have to be equal to or lesser than D21 through D24. Now, again, let me stop for a moment and make sure that you understand, all right? These figures here, allocations, all right? And the profit per bag, okay? And the time available. Getting these figures, as I've said before, would be a whole would be a class, okay, and it would be probably one class in optimization resource development. In other words, figuring out how do we use these. And a lot of management people who study operations research or get a degree in management science, which we don't offer here, there's an entire course that does nothing where you figure out where do I get these data? Because if they're garbage, no matter how beautiful this is, you got garbage. Okay, and so we've got the left-hand side of the round. We've got everything ready to go, and let's go ahead and click solve. Well, of course, it's a simplex LP. And it's going to say we found an optimal solution. And if I want the reports, again, I'll click up here and I'll get the answer report, the sensitivity report, and the limits report. And I'll click OK, and it will throw those out there for me. And we'll spend some more time, as we go along, looking at these reports. But right now, what I'm trying to do is to get you to kind of understand overall what's going on, and then to feel comfortable navigating through, okay, and putting those figures in. Now you say, so I could, if I wanted to, Dr. Harmon, generate random variables for these, okay, and random variables for these, and see what it looks like. Yes, you could do that. Now, in truth, Solver already does it, but Solver will only do what you tell it to do. Okay, I was in a faculty meeting, it's last semester, and somebody was complaining about Banner, and what I said was, which I didn't make that person happy, is, you may have to be smarter than Banner. Okay, and so we have to be smarter than Solver, so that we know what we're putting in here. And we got the bags produced, okay, and we've maximized the profits, and we can calculate the total profits pretty easy. I can take 10 times 540, 9 times 252, and I know what I've got. And and of course, there it is, the maximum total profits. Okay. Well, I started about 10 minutes early, okay, and it's 11:39, and so we've gotten our 50 minutes in, and so I'm going to do this. I'm going to close this off, and of course, if you can always go back and take a look at it, okay, and I'll just go back here quickly to the modules so we see what's going on. Squeeze this up. All right. Now, we're on module 1 now, and Friday, Nolan Plastics is due. That's 5 o'clock, if I'm not mistaken. Then chapter 1 quiz is due, or exam. Chapter 2 exam, and both of these are over the management science text. All right, and then here's what will happen. On Monday, which is our ground-based session, I'll come in. I'll show you the key for Nolan, okay? And then we'll take a look at, and then I planned on Wednesday the 14th to screencast a preview M&D chemicals, but we're a little bit ahead of that, so I'll probably jump ahead to the next week, okay? And that would be the cases that would be due here. And you've seen us do this before, so we'll be okay. And then, well, what I'll do next, then I'd do that week, would be to cover the key for those, okay? And then on the 16th, you're going to have PAR Inc. is due, Chapter 3 and Chapter 4 is due. So I'm kind of jumping ahead, so, and previewing some of these cases, but they're due when they're due. And all I ask you to do is just try them. Okay, and then I'll show you that when I go through the solution, you'll see the solution, but I want you to just try them, okay? So you get comfortable navigating and working with them, and just simply trying the case, and you get credit for doing that. That's why I say that I use a workshop format, because on these cases, I have you just try, and then I show you, what we're doing, so I can focus on the more important stuff about, like what we've been doing now. We've looked here at a profit maximization, okay? We've looked at a minimization problem, okay? And then we looked at Nolan, and that was a particular type of problem again, okay? So that'll pretty much do it. I will see everybody in class on Monday. Now, you say Friday is a virtual day too. Yes. Friday is a day for you to upload. You can spend Friday, okay, getting PAR Inc. completed. You could do Friday to do your exams. I would do it before, but they're due when they're due. And that's why I say Virtual Friday is kind of it's a virtual lab day, but it's basically an independent study day. Okay? Well, that'll do it, folks. Thank you so much for your time. I appreciate it. And I'm going to stop the share, and then I'll record this and post it over here at Canvas. God bless you and take care.